Just one time, 10 points altogether. The whole thing. All right, number 6. The 2x cubed. Okay. Yeah. All right, this is number 6 on the back of the page that starts. This is homework. So we're going to run through an analysis here and see what happens. Let me get my camera rolling. First thing I want to do is type this equation into my calculator, because I'm going to let the calculator do all the hard work for me. All right, so y equals 2x to the third minus 7x squared plus 6. I'm going to start with a zoom 6 here. See if I can get everything in there. And it looks like I got everything in there pretty good, because I know a cubic can't have more humps than that. So I've got everything I need in my picture. So the first thing asks for domain. So what's the domain here? Negative infinity to infinity. How about the range? Negative infinity to infinity. That's exactly right. Relative maximums next. So it looks like I just have one, and it's here. So I'm going to go second trace. I'm going to choose maximum, which is number 4. Now, you see my spider there that's blinking, right? I'm going to put him as close as I can get to the maximum, and then I'm going to click left 1, 2, 3 times and hit enter. Go back to where, roughly where you think it is, and then hit right 1, 2, 3, and now you need to do enter, enter. Remember, if you see something like this with the E, with a negative number like this, that's 0. Okay, so 0, 6 then is my maximum, and I'm going to sketch this out for you. This is 0, 6, because it's going to help us with the increasing, decreasing if we go and put these points on here. All right, what else do you see? Yes, because that E negative is scientific notation, and it rounds to 0. I'm going to go ahead with this minimum. So second trace, this time I'm choosing minimum. Again, I'm going to put my spider close to where I think it is, and then it says left, so I'm going to hit left 1, 2, 3 times and hit enter. I'm going to go back to where I think it is, and I'm going to hit right for right bound 1, 2, 3 times. Enter, enter. Yes, yep. 2.3 negative 6.7. You don't have to. I mean, you can if you want to. It's not wrong. Okay, so this is relative max. This is relative min. Why are they not absolute? Goes up and down forever and ever and ever, so they're not absolute. Now, I also asked you to add on here to find the zeros. How many zeros do you see here? 3. I see 3 as well. 1, 2, and 3. So I'm going back to my calculator to calculate each one of these. So second trace, always going second trace, because that's how I calculate things on my graph. Go to 0, and again, I'm going to put the spider where I think it's close to the 0 I'm looking for. I'm going to just start with this first one here. I can't get it exactly on there, but it doesn't matter. Okay. To the left, 1, 2, 3, enter. Go back to where you were, and then go to the right. 1, 2, 3. Enter, enter. Negative 0.8320. Negative 0.832. No, you can just go 2. Again, for the next one, I'm second, calculate the 0. Go close to the 0. It doesn't have to be exact. That would have worked if I went there or there, doesn't matter. And go left 3 times. 1, 2, 3, enter. Back to the 0 and go right. 1, 2, 3, enter, enter. 1.123. 2 decimal places is good. I'm at calculus, we have to go out to 3, and I get, when y'all come in, I'm still in calculus mode. 1.12 is good. And now my very last 0. See, the calculator is doing all this for you, but you definitely have to know how to make it work here. So I go to the last 0 here. Left bound, so hit the left button, 1, 2, 3, enter. Go back where you started. It says right bound, so I'm going to hit the right button, 1, 2, 3, enter, enter. 3.2. Really 3.21, I guess. There are my zeros. Go okay. In behavior, you have 2 n's. As x approaches infinity, f of x approaches blank. And as x approaches negative infinity, f of x approaches blank. This says on the right side, is it going up or down? Up, so it's positive infinity. On the left side, is it going up or down? So that's negative. One last thing to do, and that's my increasing and decreasing intervals. Where do those change? Where do my increasing and decreasing intervals change? On the humps. What are the humps called? Turning points, okay? Those change because it turns, it changes direction. So as I start, this is negative infinity, this is positive infinity. I helped someone in here yesterday with it like this, and then I ended up teaching it like this in 3rd block, and they understood a little bit better. So let's see. As I go from negative infinity up to this turning point, am I increasing or decreasing? Increasing. Why is that increasing? Because you're going up. As you read it, just like a book, as you go left to right, it goes up. Now from this turning point to this turning point, am I increasing or decreasing? Decreasing. And now there are no more turning points, so from this point to the end, what am I doing? Increasing. Now it's a little bit easier to write the intervals. So what I did was I come over here and say increasing, decreasing. Let's look at the first interval. The first interval goes from negative infinity. Remember, I'm using the x values from negative infinity to 0. What is the function doing? Increasing from negative infinity to 0. From 0 to 2.3, what is the function doing? Decreasing. 0 to 2.3. From 2.3, this time I go to positive infinity. What is the function doing? Increasing. So I have something else I need to add here. So to add it, I add it with a u, and I go 2.32. Yeah, well, no, you do it from the maxes and mins. What do you mean? Yes, because you need to make sure you round that to zero. That's just that's an error on your calculator. You have to be able to, and that will happen all the time. Oh, like the type and all. So what's the degree there? 3. What's the type? It's a cubic trinomial. That's exactly right. What's the leading coefficient? What's the constant? Without a variable. When the degree is 2. Everybody okay? Anything else? If I need you to do it, it'll be a place. You should already know this because I have already taught you this yesterday. So the point at which the function the zeros are the point at which the function intersects the what? X-axis. You may not know this, but you might based on the number of humps. A polynomial function of degree n can have at most how many real zeros? Excuse me. Yes, again. Nope. Okay. How many can a quadratic's degree is what? 2, right? How many zeros, what's the most number of zeros it can have? 2. So it's got 2 or less, right? Zeros. How about a cubic? What's its degree? How many zeros could it possibly have? What's the most number it could have? The most number of times it could cross the x-axis. 3. Yeah, it's 3. I'm sorry. How about a quartic? So this time, what's the most number it can have? 4. So it can have 4. So if the degree is n, what's the most number of zeros it can have? N. The degree tells you the most number of zeros. That's actually the fundamental theorem of algebra. The degree tells you the number of zeros. Now, and we say number of zeros because they could be imaginary and they could be what we call repeated, which we're going to talk about today. Okay. Well, then it makes sense that an even degree polynomial has an even number of zeros and an odd degree it has an odd number of zeros, right? Okay. Number one takes us back and it's a little bit of review. So it's just graphing to find the zeros. We just did that. Do y'all need me to do that with you? You want me to do one with you? Okay. So let's look at the first one. X to the third. What? Yeah. Y equals x to the third plus x squared minus 2x. I'm going to do a Zoom 6 because that's my favorite. And it says to calculate the zeros, okay? So notice here, I do have 2 zeros here, and it's kind of hard to see, but that does loop down under that and pass back up. So what I might need to do is hit my window and zoom in a little bit on that. And to do that, I'm going to change my y's, -2 to 2 maybe. That might do it. Let me see before you do it. Yeah. I just really want to be able to see those zeros. So if I calculate the zero, I'm going to go left, and then right, and then enter. I got -2 as one of the zeros. Yeah. I adjusted my window. Did you put -2 to 2 for the y min and y max? You don't have to. You can calculate it without adjusting the window. I did that because I wanted to squeeze in and look a little bit closer because all I'm worried about is where it crosses the x-axis. Just the zeros here. We're going to talk about just the zeros for just a minute. What's the zero? You didn't do the negative first. The y min has to be -2. The y max has to be +2. Can y'all see? It's kind of dark, isn't it? Is that better? Enter. Hey, that's better. All right, so you go through and find those other two zeros and see what you get. Yeah. Everybody get 0, 0 for the next one? -2 zeros is the first one. That's correct. I usually just do x equals because you know if it's an x intercept, y is going to be 0 anyway. You see what I'm saying? One is the third one there. Is everybody able to get those? So this is a graphic approach to zeros. But we've also talked about how to find algebraically how to find the zeros. So if you skip down to number 3, this is going to be finding zeros algebraically. When we have an equation and we want to find the zeros, does anybody remember what we do? Yeah, like an equation, not a graph, but an equation. We set that equation equal to 0. That's okay. And then we factor and solve. And it tells us where it crosses the x-axis. So for example, this, by the way, when we factor it in what we call linear factors. That just means we factor it down where there's no exponents in the x. You'll see that it's completely factored is what it is. But for example, on number 3, I have f of x equals x to the third minus 2x squared minus 15x. So to find the zeros algebraically, I'm going to set it equal to 0. And now I'm going to try my best to factor it. So as I factor this, remember, what's the first step in factoring? Greatest common factor. That's exactly right. Does this have a GCF? X. You're exactly right. So if I take x away from everything, what's left? That's exactly right. Now factor what's in parentheses. Hopefully we remember factoring, right? Multiply the first and the last together. What multiplies to negative 15x squared but adds to negative 2x? That's exactly right. Negative 5x and 3x. It's negative because it has to add to negative 2. Oh, yeah. All right, so I've got x squared. I'm going to rewrite this middle as minus 5x plus 3x minus 15. Yes. Well, don't worry about this one in front. I'm only looking at what's in parentheses. All right, so this is where I slash it. Remember, factoring is one of those things that when you leave here, I want you to be able to do it backwards, forwards, left, right, up, down in your sleep factor quadratic. So I have 0 equals x times, what can I take out of x squared and 5x? X. It leaves me with what? That is correct. I take the middle sign. What can I take out of 3x and 15? 3, and I have left with x minus 5. The x stays on the outside. I've got the x minus 5, and I've got the x plus 3 that's left. And it is now completely factored. Now, I did that not so that I could make it look pretty in factored form, but I did that so that I could find the zeros. So now I use that property that says if I multiply 2 or more things together and they give me 0, then one or more of them must be 0. So I take everything and I say, okay, x equals 0, x minus 5 equals 0, and x plus 3 equals 0. And I solve each one. Does it make sense that I would get 3 zeros here? Look back at your original equation. Why does that make sense? The degree is 3. I can have up to 3 zeros. If I graph this, so let me just do it. X to the third minus 2x squared minus 15x. Well, would you look at that? It does appear to be crossing. What did we say? Negative 3, 1, 2, 3, 0, and 1, 2, 3, 4, 5. We found the zeros algebraically. We confirmed it graphically. Does that make sense? Okay. I just want you to see how all this comes back together and we're doing the same thing. All right, flip it over. Now we get to talk about something new. This is the one new thing for today. I want you to think about, before I explain the concept of multiplicity, I want you to think about this equation here. In fact, instead of just thinking about it, I want you to factor this completely. That looks like a special kind of trinomial. Everybody factor down that way? Does that make sense to everybody? I didn't show all that work here. This is actually a perfect square trinomial. Remember if it's square dances? If I asked you to find the zeros algebraically here, what would you tell me they are? 3 and somebody said it. 0, right? But I told you that the degree tells me how many zeros I have, and I only see 2. Okay? This is what we call a repeated solution. It's called a repeated solution because, look, it tells me it's in there twice. Okay? That twice is called the functions or the zeros multiplicity. Ooh, Stacy, spell it right. Multiplicity. And all multiplicity means is it's the number of times that that factor happens, okay? So we say x equals 0 is a solution. X equals 3 is a solution with multiplicity of 2. Meaning it happens twice. The factor happens twice in the equation. That's all it means. So the zeros of this are 0 and 3, but 3 has multiplicity 2. So now you might be saying, well, that's all well and good, but what in the world difference does it make? And it actually makes a big difference, and here is why. If a 0, I don't even know if this is on your sheet. Oh, yeah. Has even multiplicity. So I actually skipped down to that second bullet. Let me just show you. X to the third. I'm not going to do it in factored form. I'm going to just do it in regular. Minus 6x squared plus 9x. 0 and 3 are my two zeros, right? Why is it taking so long? What the heck? X to the third minus 6. What the heck is, okay, there we go. All right, notice this. Notice this graph here. Here is my 0. By the way, what is 0's multiplicity? In other words, how many times does it happen? How many times in the equation? 1. This one, 0, has multiplicity of 1. But this one has multiplicity what? 2. What happened here? What's the difference in this 0 and this 0? What I'm touch and go. That's exactly right. That's a good way to say it. I like it. That's good. We actually, mathematically, we say if it has 0, it bounces. But I like touch and go. It bounces. The vertex sits on the axis, okay? Anytime you have even multiplicity, it means that the graph bounces off or touches the axis and goes. It doesn't go straight through. If you have odd multiplicity, this is when it goes straight through. Yep. Odd multiplicity because the graph goes straight through the x-axis. This one has even multiplicity because it bounces off the axis. It never crosses the axis. It sits on there at one point, but it never crosses over. That's right. Touch and go, like Aiden said. Touch and go. Bounces right back off of it. Yes, if it happens. So this is the same thing as it being in there twice. The multiplicity is how many times it's in there, right? So it's 2. So that would be the multiplicity. Does that make sense to everybody? All right, well, let's look at number 6 then. We'll graph it together in just a second, but just to make sure you understand multiplicity, let's look at this little chart. This is quite the complicated. You will get to where you can factor a polynomial like this, but right now you can't factor one quite this large like number 6. But number 6 says f of x equals x plus 7 squared times 2x plus 1 times x minus 4 to the third. And you've got a little chart, 0, meaning what is the 0? What is its multiplicity? And what is its effect on the graph? And by effect, I just want you to tell me, does it bounce or touch and go, or does it go straight through? Okay. So what's the first 0 you see in this equation? -7. Why are you saying -7 and not +7? I have to say x plus 7 equals 0, so x equals -7. So my first 0 is -7. What is its multiplicity? 2. In other words, how many times does it occur? What is the exponent on the factor? What is the effect? It's a bounce. As long as it's even, it's a bounce. What's the next 0 you see? Close. -1/2. Remember, subtract 1 and divide by 2. What is its multiplicity? So what does it do to the graph? Straight through. Straight through. What's another 0? What is its multiplicity? What does it do to the graph? So if I graph this, I should see that at -7, it bounces, and then at -1/2, it goes straight through, and then at 4, it goes straight through again. So put it in your calculator and see. In your calculator. Put it in just the way it's written there, x plus 7 squared, 2x plus 1. I think these are cool. Y'all don't have to. Oh my gosh. What the heck? No, mine's not right. Mine's. Y'all's look like mine? Yes. With the broken piece? Yes. Yeah. What the heck? Maybe we need to hear. Is not factored for us. So you have to first factor it. And what do you take out first? X what? Squared, that's exactly right. X squared, it leaves me with x squared minus 2x minus 8. Little shortcut if you haven't figured this out yet, if you still factor the long way. This only works when your leading coefficient is 1. What multiplies to -8 but adds to -2? -4 and 2, right? You can do x squared, x minus 4x plus 2. That only works when you don't have a leading coefficient here. If you have a leading coefficient, you have to multiply them together, find the factors, and slash it. All right, so I have what zeros? What are my zeros here? What's this one? Not just 4 and -2, but also 0. Multiplicity. What's the multiplicity? 2. It's 2. Multiplicity is 2 here, which means what happens? It bounces. That's exactly right. How about 4? What's the multiplicity? So what does it do? Straight through. How about -2? So what does it do? Straight through. I'm going to graph this not on the camera first. Okay, this one works. These all have multiplicity 1, so they go straight through. So if you graph this one, this is what it looks like. So straight through at -2, bounces at 0, and straight through at +4. All right, here's what I want you to do. So the graphic organizer here takes you really through everything you're going to do for all the rest of them. It's just a little bit easier to read, but so you can keep up with everything. It's exactly what you've been doing. The only difference is you've added, I don't even think multiplicity is on this one. You'll add multiplicity onto these. You don't have to write a paragraph. But what you do want to note for each one of these, and let me write it out for you to be a little easier. You don't have to, but you want key characteristics. So key characteristics include, so if you just want to list them, 1, the type. What does type mean? Cubic, quartic, quadratic, that kind of thing. The domain. It's everything we've done. Yes, but added multiplicity to it too. It's listed up here, but it's in paragraph form, so I was just showing you, if you write it out, what all you have to do. In behavior, maxes and mins. These are listed as turning points. See, remember I told you whenever we finish this unit, there'll be like 12 or 13 different things you'll be finding. Zeros, along with their multiplicity and the effect. There's really 2 things, but that goes with the zeros. I think that's it. Yeah, I think that's it.